topics, many times security, since that's what we do here at Duo. To kick it off, I wanted to open it up for any announcements that people might have about local events, conferences, people that are hiring, whatever else. And I think we can throw around the catch box back there. If you just raise your hand and we'll throw something at you. If you have an announcement, we got one right there. Wait, you got talking to the box.
Anybody involved in automotive-related security? scorecard deadline for presentations is February 26th. So look about for scorecard, which is at University of Michigan. Michigan Transportation Center hosts it, and it's in June, but the submission deadline for presentations is February 26th.
And there's like a NDIA conference coming up in a couple weeks. Doug, do you know where that is?
No.
Cool.
One other thing, there's also
Detroit.
Yeah, coming up actually in the same spot here in our office is an event for Techstars, which is a startup accelerator. They have a chapter out of Detroit called Techstars Mobility, but anyone who has an interest in building mobility-related startups can join us here 5 p.m. Wednesday. Wait, what? Tuesday? Where's Rachel? Anyway, well, if you look up Tech, what's that? Techstars is Tuesday. Thank you. All right, Techstars Tuesday at 5 p.m. Great. Anyone else?
Hi, I'm Emily. I'm one of the chapter leaders of Girl Develop at Ann Arbor here in town, and we have events going on all the time, but one that might behoove people here is we're doing a public speaking through Lightning Talks workshop. So if that interests you and you want to get better at it, we have a 4-part workshop every Tuesday in March, starting March 8th. So, yeah.
All right.
I couldn't find the details.
Here, use the box for now.
Check.
So, yeah, it's the National Defense Industrial Association event. It's in Detroit. They have a whole event on automotive security, and our good buddy Mudge, who was a previous speaker here, is going to be at that. So, Google for NDIA Detroit. It's coming up in a couple weeks if you're interested in car security. Anybody else? That's it. ARPSEC. Yeah, March 9th. ARPSEC. 6 p.m. at Braun Court, 327 Braun. ARPSEC.org.
I don't actually know all the details, but there is a Android security meetup with the Google Developers Group, I think next Thursday, in this building, Arbor Moon.
Cool. All right. Nobody else?
It's yours now.
Yep, you get to keep it. All right, our speaker today is Mark Stanislav. He's from Rapid 9, I think he said. Rapid 9. Rapid 7. And I've been told that Mark is CompTIA Linux Plus certified. Is that true? Congratulations.
That wasn't a recent thing, by the way. That was like 2006. But anyway, that's still my entire bio. I have nothing else to show.
I might. I don't block that out. Mark found his first CVE 6 years ago.
Wow.
Yeah. It was the WSN Links CMS SQL injection vulnerability. I have the email. It's framed on my wall at home. I read it every night before I go to bed. And that was, I guess, when Mark and I first got to know each other. And since then, Mark's career has just absolutely taken off. Of course, all thanks to Duo. No. Mark's done a lot of interesting security research. I'm not going to read his full bio here, but he's talked at thousands of events, hundreds of thousands of events. Every security conference that's ever happened, Mark has been there keynoting, pretty much, yeah. And every single device that has existed or may exist in the future, Mark has hacked. And I think he's talking about all of them today. So give Mark a nice round of applause.
I agreed to speak just so John could introduce me and come up with that. So I think it was worth it for all of us. So tonight's talk is a little bit of a compilation. The kind of first larger chunk of this is research I did on connected baby monitors back in the fall that I released. And then the other research at the end is actually, hope this goes well. The end is actually 2 new research projects that I released publicly on February 2nd. So some new content, first time this content's being presented. So that's pretty cool. And we'll see how long this talk takes. So let's see, 40 after, okay. So, aside from Antoine Dodson, my Google image skills also extend to Dr. Strangelove. And this is something that you'll find through the talk is probably 100 or 98% true. The Internet of Things has been interesting for me, especially to watch in the news and the coverage of certain researchers and research projects of IoT. And the kind of contention I have with IoT is interesting because of scale, right? IoT's sexy because of scale, but then there's a lot of research that says, oh, you can totally own this Internet of Thing device if you are next to it, like within 4 inches, one at a time. Yeah, I mean, it's still good research and it's still useful and it's still good to fix bugs, but the whole IoT revolution and the security concerns we should have are ones of scale and ones of mass compromise and exploitation. And you'll see this very quickly that web services, the back end, whether it's mobile APIs, message queuing systems, or whatever else, these things all are the really big risk and the big attack surface. So if you want to own one device at a time, cool. If you want to own all the devices, slightly better. And to that point, the composition of IoT devices in general is pretty broad, and I think some of this doesn't maybe get pointed out often enough. The actual vendors putting this stuff together are not usually first parties. There's usually components from third party and third party and third party. There's web service A and B and C. There's platform as a service this, infrastructure as a service that. And so when you buy a device off the shelf that's an IoT device, you aren't buying a product from X vendor. You are buying a product from X vendor with A through Z vendors behind it, and where your data goes, the kinds of content that is being pulled into cloud services that you have no idea of the retention policies, the security controls around it, and then the actual firmware running on that device very often is actually just firmware that is a original design manufacturer for the chipset that you're using. The actual vendor has never looked at the firmware. They've never removed default accounts. They've never updated binaries. They've never updated glibc as relevant today. So all these things come into play, and we don't really think that hard about it often enough. The other thing that happens is with IoT, when someone says like, oh, I'm going to go hack an IoT device, it doesn't really mean anything. And the reason why is because this list, as a short list, the complexity of an IoT deployment is not just I have a device and it's internet connected. It's all the radios, it's the firmware, it's the physical serial connections, JTAG, it's the cloud services, the mobile apps, the APIs, everything ties together. And if you don't take everything together, then you're really missing the whole ecosystem of an IoT device. IoT devices are not singular things, they are ecosystems. The reality is, though, of course, if you're a vendor, vendors screw up, bugs happen, that's okay. We expect that to go that way. The thing is, with IoT, we're seeing a very high failure rate when it comes to security, and we're seeing failure rates for areas that should be really low-hanging fruit to your average software vendor, and we're not. Today's talk is a lot about low-hanging fruit, and now normally that doesn't make for an exciting talk, but again, when you're talking scale, and you're talking mass compromise with one HTTP request, it slightly becomes more impressive, right? So these are issues where IoT is very mature. As Zach Lanier and I said many times on stage for IoT talks, we're in the nascency of IoT as a whole. There's a lot yet to be determined, whether it's standards, frameworks, platforms, and so on. So one thing I wanted to start with is just a little really brief primer on how people go after, and this is really more almost like a hardware hacking thing, because IoT at part of the basis is of course hardware hacking, but we also cover some stuff more technical, networks and things. So just as a survey course in about 3 minutes, if you are curious to get into some of this stuff, these are some things that are very easy to do for the most part and very repeatable across devices. So one thing that you have to do usually is ideal to get the firmware. Now sometimes you can download the firmware off a website. You find a download new firmware link or something to upload to your device. More and more often, though, that's not true. More and more often, the actual updating of the Internet of Things platforms are actually all back-end. There's actually not user interaction other than to say, yes, I want to update my device on my mobile app, and then it pushes firmware, pulls firmware, or whatever. So one very efficient way is to actually just dump the firmware off of the actual flash chip. These, flash chips in these what's known as SOIC. I say SOIC. Everyone else seems to say SOIC, which is really boring. You can get this Pomona clip, or an off-brand, which you shouldn't. But you get the Pomona clip. You get something like a Bus Pirate, a Shikra, or anything else that can speak this serial peripheral interface protocol, so SPI. And it literally just reads bit by bit off this chip, and you get the entire flash dump. And then you can start, you can find file systems, you can find data segments, you can look for whatever you want, start reversing binaries, go crazy. So very quick means to an end. Flash ROM plus that is basically get firmware. Once you have firmware, of course, you want to get data extracted from it. That's where binwalk comes in. Again, binwalk is pretty much run and you get stuff out. Now, sometimes there's obfuscation, sometimes there's encryption, sometimes there's just bad deployments of file systems. You never quite know what you're going to get, but at least that gets you started with getting some stuff. Which often leads into brute force. So once you get a firmware image, once you extract a shadow file or htaccess file or something, you might have some passwords on there. Some of the passwords might be defaults that you can change as a consumer, but very often a lot of the passwords are actually hard-coded. You as a consumer don't know they're there. They might provide access to an SSH that's daemon that's listening, telnet daemon, very often telnet sadly still, daemon that's listening, or web services that aren't told about in the user manual. The other side of that coin, so you can crack stuff with, octal hashcat or whatever. The other side of that coin is brute forcing from the perspective of you have some knowledge of maybe an API, or you have some knowledge of a domain that you found reversing a mobile app. You can then kind of go to Google and just say like site : weird domain or site : weird subdomain. And in this example, one of the devices we're talking about tonight, there's literally user posted data for account information just indexed to Google. And I found that by finding one obscure host name in one binary and then looking on Google for it, right? Like these things very often cascade. So there's a little bit of magic and a little bit of hope, but oftentimes you find some cool stuff. Joe Grand, the famous Joe Grand. You probably heard about JTagulator if you came to his Duotech talk a little bit ago. One of the things JTagulator does aside from JTagulating is it also UART tagulates or something, where it will enumerate pins looking for UART connections. It'll try to find out what the baud rate of the serial connection is and help you when you're kind of doing exploring on hardware. You can also do this Bus Pirate, Shikra, and some other stuff. UARTs, it's really the means of serial console in most embedded devices, at least that I see. I'm sure there's other common ones, but UART's very popular, and UART on devices tonight that I'm talking about, I think there's a UART on every single one I found. And so effectively, you get a connection, you plug a couple pins in or solder some pads or whatever, and you get various things. You can get sometimes to the bootloader configuration. So let's say you get U-boot, which again is a very common thing to see on embedded hardware. You get U-boot and you don't have a password to the file system. Maybe you dumped the file system, you couldn't crack the shadow file, whatever. With U-boot, just like any other kind of bootloader, you can pass arbitrary kernel arguments. So you pass one or single, which is the same thing, and now all of a sudden your kernel says like, oh, you want to drop to single user mode. It bypasses authentication. You literally have access to the file system, and you can just change the password on the actual shadow file. So you have that kind of option. The other thing you can do is, another very common thing is you don't get a login prompt at all. You get literally dropped to a shell, and you just have root access. That also is very, very common. So we see all kinds of things, but again, once you have this serial console, a lot of things kind of go in pretty good direction. More, again, purposeful use of a JTagular is actually, finding and enumerating pins for JTag. Once you have that JTag, so JTagular is, again, Joe probably would say if he was here, you aren't actually interacting with JTag over JTagulator. You're enumerating pins, finding them, testing them, and making sure that ID code and stuff like that works. Once you have that, you can use things like a JLink or a Shikra and actually interface with the JTag interface, and you can do cool things like dump all the memory via GDB remotely. You can do things like halt the operation of the chip, alter memory. So let's say you had a kernel that had hard-coded kernel parameters that you can't change with U-boot. You can literally halt execution, go into memory, add or delete whatever you need to do, some bytes, and you literally can force single user mode on a kernel that would otherwise be immutable. So crazy stuff. You can do these things. It's actually not that hard, surprisingly, because our tools are so good these days. That's the crazy part. So the other area, and really kind of the lion's share of a lot of research that I've done for various terrible things with IoT, is mobile applications. Mobile applications, especially when it's an Android app and you can just use Dextojar, look at some Java, that's pretty okay usually, and start reversing through some stuff, and hopefully you find some interesting things. Maybe you find, as you'll see, hard-coded passphrases, you find hidden URLs that you didn't know API endpoints existed for, whatever the thing might be. You can also do man-in-the-middle on all those mobile apps, Midem Proxy, which Chris Zub, who I didn't see tonight, does some cool Midem Proxy additions. And so you can actually intercept traffic with that even is SSL TLS, as long as it's not pinned, but even if it's pinned, you can work your way around that without too much trouble. And then with iOS, once you decrypt the iOS app, because that's slightly more annoying, you can go through, you can open it up in IDA, you can do whatever you want. Very often, though, like I said, hidden API endpoints, credentials, a lot of other ASCII, just by dumping the binary out and looking for some strings, you're going to find a couple interesting things at the very least. All your basic network research, so Wireshark to do PCAPs, and then Nmap to find some ports. Web applications, and obviously the lead into the talk kind of alluded to this, but there's a few different angles to this, and we're going to get a little bit deeper in as we go. It could be the entire web service supporting an entire camera platform has cross-site scripting and no HTTP only on the cookies, and it's over, it's clear text. Very often, there's a lot of firmware that has hidden web interfaces that the developers didn't actually build an API. What they did is they stood up a web app, like a full web app, and they just send HTTP requests to this web app. But they've never documented the web app. They don't give you direct access to the web app. It's just kind of there. And then it turns out it's a whole new configuration interface, usually with default creds, right? All right, so that's a really quick, heads up on hardware hacking and some other stuff that's useful. So again, I encourage you to break some of your stuff because it's not that hard. This came up as I was doing the research, so this is back from March. CSI Cyber, I guess their first episode had baby monitor hacking somehow. I didn't watch the episode because why would you? But Dave Eitel, of course, comes up with this comment about junk hacking and stuff. And then Jen Ellis, right on it, who runs, I think she has a cool title like VP of all things PR or something, now at Rapid7. She sent me this email without missing a beat, sorry that CSI Cyber beat you to your research. And I kept going, though. I persevered. It hurt, but I went on. So this is kind of a hit list of the stuff we're talking about. I should say that this talk, as it is now, there's some stuff cut out from the previous talk. I try to keep slightly more of the content I liked. The other thing, as you look at this list of vendors and features and X, Y, and Z, the reality is doing 9 cameras as a research project at one time is a terrible idea. You literally have to just skip stuff. There are bugs that I just didn't bother reporting because literally typing up the disclosure was not worth my time. So there's stuff in here that if you're looking to hack stuff, I guarantee there are more bugs in all these things. Go crazy. But I wanted to point out price points and Amazon rank and feature set and all these things, right? There's a very big differential of $60 and $260. And so one of the questions to ask yourself when you're looking at security is, can you buy security? And we're about to find out the answer is no. So the first one, which I actually kind of really like the design and the mobile app on this one is the We Things or Y Things or whatever, their baby monitor offering. And this is a good example where you as a consumer put a lot of faith into what you're buying, right? And when you have a feature, when it's monitoring your home and looking at everything you do and hearing everything you do, sometimes you want to turn cameras off. Sometimes you want the camera to go away. With this particular application, this says it's disabled. I pulled out some stream information for RTMP. 5 minutes later, kept working. 10 minutes later, kept working. 20 minutes later, kept working. It actually just, I think, kept working. I just stopped caring. I was like, well, if it's working 20 minutes after, like, we're past the point of this being okay. So I'm just going to stop wasting my time now. And so this is an example where we as consumers put a lot of faith into the mobile apps that we see. The user interface is gospel. We do not know anything in an embedded device in a black box other than what our mobile app or our website tells us is happening. And so that's kind of a big thing, right? Like, your privacy is something that you assumably want some degree of. If you turn something off, you expect it to be off. This is a really good example where that doesn't always play out the right way. This is a weird one that I kind of threw in because I thought it was funny and I guess weird. This is an example where you start reversing a mobile app or anything else, and you start seeing things that just don't make sense. So if you're a developer, this makes a lot of sense. If you're not, I'll try to walk through a little bit of it. So there's this awesome function, method, whatever you want to say, MD5 root session. Now, as a researcher, you're like, root, good, session, good, MD5, good but bad, whatever. And so you're going through this and you find like this really long concatenation operation, and there's some like weird method calls and a bunch of toStrings, and you see this mchunk, and I'm like, well, what's mchunk? Like, I'm not a Java developer per se, but I've never heard of mchunk. Well, I find that there's an mchunk method, and I go through it and look over it, and it's like, okay, so you take in an integer, you have this like static ff string, you do like some loops, and you do a for loop, blah, and it's like, okay, well, it's obfuscating some part of this string that then the MD5 hash of this email address is concatenated with the string and the result. So we just have to reverse it. We just have to literally build this piece of code and just let it run, and we will get the output and now know what the credential is. Before I ran this little chunk of code to see what happened, I was looking through it. I'm like, okay, what? And so as soon as you get into the for loop, it returns. And it returns ff, the integer you put in, and blank, and null, whatever. So all this awesome obfuscation routine that's really cryptic looking, it does nothing. It never gets hit. It never actually is executed. So again, why does this happen? Were they debugging and they forgot to turn it back on? I don't know, whatever. But either way, funny stuff. I actually kind of picked on a vendor last week where they said something. They had all this error debug in their Android app, and I was going through and reversing some stuff, and one of the things was like, oh, please, God, baby Jesus, make this work. And so I took a screenshot, of course, and posted it to their Twitter account, and they're actually pretty good sports. They said something like, oh yeah, we're trying not to have to go to a higher deity for the next release. We're fixing some code or something. I don't know. But good attitude. So this next one, this is the $260 camera, and I'm going to repeat 260 a couple times. So this is a $260 camera. It had a bunch of ugly situations, like no SSL, built-in SSL certs that weren't even used, static private keys, all that kind of jazz. But when I was going through, I was looking around, and here's Rapid7 plug, Metasploit. And so I was doing some enumeration, and this $260 device that is literally the 2015 model, because again, this is research from a year ago, roughly. 2015 model, $260, brand new, most up-to-date firmware they offered. And they have two CVSS 10 remote code execution bugs from 2012 on this device. So when you think about, okay, supply chain, you think about, oh, that's weird, and then there's no way this has ever been vetted by anyone with security in their name, right? There's just no way that a title of security has ever looked at this, because at the very least, you scan this with any vulnerability scanner, you will find this, and that's if you're not even trying. So $260 camera, brand new, 2015, and remote code execution out of the box. And you can't update it. There's no update to get rid of the remote code execution. There were some other bugs with that one, but I'm skipping over some of those. Peek of view, this is the really cheap one, and it looks cheap. I mean, look at this box. No one's put any thought into that. Terrible product marketing. And this is one that I just found funny, and this is one of those things where if you're looking for like, I don't know, like storing your wares or doing like shady distribution of malware, I don't know, you literally get your own very own FTP account when you buy this camera, and it creates an account when you sign up. So if you wanted, you could just create 1 million accounts and have 1 million FTP with unlimited quota on their file server. But this is something that's never told to you. You have no knowledge these credentials exist. You don't know what it's doing. You don't know what data it's uploading or not uploading by default. It's just kind of there, and it just kind of happens. This is another example where I don't know who the hosting provider is. I don't know if this is a SaaS offering. I don't know if this is just a dedicated box somewhere in a colo. I don't know what my data is shared with other people's data on the same disk partition. I have no idea. So when it comes to a baby monitor, you kind of want to know those things. And then we start a very long, and again, I've obscured some of these things because it's just not worth talking about over and over. This is a camera where, to their credit, they had a default credential, and default credentials are not inherently bad in a really kind way. They're not bad because they're default, and that implies that you can change them as a consumer. Now, a lot of companies don't force you to change defaults, which is a bad practice. You should get forced to change a default before you can use it, and you shouldn't use the same password as what's there. So this is an example where they have admin. You can change it. Good. But then they have user, and guest. You can't change those. Those are always there. You don't know they're there. You can't change them. You have no control. And of course, when I go to this back-end unencrypted web interface that's on this camera that no one knows about, you can absolutely look at the camera stream with user as credential. There's also a hard-coded 2601HX. There's a hard-coded admin password, which for the purposes of their bad file system is actually root. All the permissions were basically globbed to admin. I don't know why. So that's fun. This other camera, this is just a really good example of how little crypto we're talking about. So this camera has one local backend web interface, another hidden web service, kind of additionally on top of that. There's a vendor API call, all unencrypted, and a third-party streaming service where your data actually gets streamed over the internet. All of this is unencrypted, and again, this isn't the exception. Almost every device on here, except for one, is that true? Yeah, except for one had no stream encryption at all. Everything was unencrypted over the internet. So if you're in a coffee shop, someone's watching with you. TrendNet has, of course, gotten beaten up from the FTC and stuff before, so it seemed worthy to check one of their things out. Also, they were really frustrating because they had these very, very tiny solder pads and didn't have pin-throughs for their UART, so that was frustrating. But so one example that kind of alluded to earlier, they have, and they didn't fix it yet, so I just redacted it to be nice. They have this cross-site scripting bug. It's on their site. It's on the site that controls all the web streaming. The site's already unencrypted, so you're just layering on problems. But this is another thing where vendors often fix things, whether it's because they realize it's a bad practice, they realize that someone said you should fix this, and they do it. So they didn't have Telnet on this device enabled, but they had Telnet on the device. So you can depending on what your context, if you have maybe a script, that's foreshadowing, by the way, for later, to enable Telnet again, you could run it, or some other things like that. So you still have an root account of root, password of admin. So if you find a way to execute Telnet D, execute a script that could launch Telnet D, whatever, you can get back in, and that's not a great thing. So this is the iBaby M3S. There's actually two iBabies we'll talk about. A really popular brand when it comes to internet-connected baby monitors. So we see Telnet. That's already a red flag that this is going to go downhill. We see a login of admin on the default Telnet that's running on this baby monitor. And then we log in, and for all you Unix folks in here, if you see, or anyone that's not, if you see a file, first off, it's not a shadow file. That's already an indicator that something's gone wrong. If you see a password file with a section for where normally the password hash would go, that you would be like, oh, it's MD5, $1, whatever. That's a big red flag, because that's Unix script, and Unix script hasn't been okay for a very, very, very long time, just like Telnet. So we look at the IBM 3S, we do a little analysis. And again, this is a product maybe from 2014. I'll give them benefit of the doubt. So let's say a 2014 camera. U-boot from 2005, OpenSSL from 2007, actually too old to be affected by Heartbleed. So security, everyone. Linux kernel from 2007, BusyBox from 08. And then, of course, they're using Unix crypt, which, again, if you're not familiar, truncates passwords to 8 characters. Whatever you type in, it doesn't care. It's going to truncate it. 8 characters is all you're getting. And then Telnet, of course, has been around forever, and we're way past that with SSH. So, again, brand new camera, fully patched. Like, you as a consumer, this is what you get. This is all you're going to get. You're going to get a Telnet-enabled admin, super out of date, has a ton of bugs. Day monitor. They have some encryption, and they have some encryption by the way of you have a export you can do of like the configuration of the device, which is good. That's a good feature to have. But of course, like every other terrible crypto thing that ever happened, they have a hard-coded passphrase, which isn't a good passphrase in the first place. So if you ever find one of these backups or however you get one, you can just decrypt it immediately. Someone also might want to make a ECB joke, but I'm not that guy. So the other thing is they're using, for some of the stuff they're doing, they're also using XXT, which even if you think like you care about crypto, you probably have never heard of XXT. How many people in here have heard of XXT? Maybe is the other way to do it. Where's David Adrian? I feel like he should. No, David's not here. Okay, he would have probably known. But I'm trying to think if it's. I think it's known plain text. It's got some number of attacks against it. That's not a great thing. And we have plenty of other block ciphers that could be used, or stream ciphers or whatever else. So it's just one of those things when you see something like this, the reason why they're using XXT, more than likely, I'm just taking a guess here, is because the hardware is really underpowered. And the only way they could actually do crypto operations at the speed they wanted is by using a cipher that's not super operationally powerful. One of the recurring themes, and I've actually verified this with numerous vendors I've worked for over the years in the IoT space, these devices, up until maybe this year or maybe last year, in some cases for a really good brand, a lot of these devices don't do crypto because they literally can't keep up doing the crypto operations for streaming video at like frame rates they want and the quality they want and everything else. And that's kind of a reality of the hardware. That's also a reality, though, of margin. These companies need to make money, and this isn't like the most lucrative thing ever to put on, because remember, you're buying the hardware, sure, but you're almost always buying free service for some amount of time, and they have to consider all that when they're putting their sales ideas together. So you might have something that has crypto, but it might not be great crypto either. IBM 6, beer break. So IBM 6, definitely the most annoying thing to get apart. Look at this thing. It's like BB-8 or I don't know. So a lot of the stuff we talked about before was like, okay, that's bad, that's not ideal, whatever. Now we're in like the last couple monitors where we're going to talk about like really not good things. So the iBaby monitor, this web interface for their site, this isn't something that I was readily exposed to. I kind of found it through some like Google dorking and some other stuff. In terms of like logging into it, obviously there's like an API call down here too, but I was like, oh, it's an API, whatever, because /API, right? So this web interface wasn't something that was super like obvious that people should use. It like wasn't documented anywhere that I could find. So you have an unencrypted website that's taking credentials into login. You've got unencrypted mobile API calls when you register and authenticate and everything else. All your creds are going over the wire. Maybe they were MD5, I don't remember, but not good either way. And then, of course, same vendor as the last, default login, Telnet, HTTP, all by default. So we're setting the stage here, but it's going to go much further downhill. So until I say what it returns now, I don't know if it actually returns that now, but when I took the screenshot, that's what it returned now. And this was the website, and that used to not happen. It used to not throw an error on login. What it used to do is let you log in. This is where the Dr. Strangelove thing starts getting really intense. So you log in, you're like, okay, cool. And you log in like anyone that looks at any web interface ever. You're like looking at parameters, you're query strings, you're looking at posts, you look at cookies and sessions and whatever else. In this case, the discerning eye will immediately go up and be like, oh, cool, there's like a serial number up there. What happens if I log into a good account and a bad account? And one of the accounts is actually registered for this camera, and this guy is not so much registered for that camera. So this is what's somewhat maybe familiarly known as direct object reference. I'm picking what object in this database I actually want to return for. And as long as you're authenticated, and any one of us at this time could have created an account. There's no restriction. You don't have to have a device in your home to actually register an account. So you register a fake account, you look at that serial number, which is hexadecimal, well, not hexadecimal, the first part is, but the last part is actually a fixed string. And then you go through, you log in as your attacker account, you go there, and you're like, okay, cool, there's some info. But then you go through like some of these tabs, and very quickly you see this alert information. I was like, oh, weird, like the images are broken, and like that alert info, whatever. I'm like, actually, those are alerts that I had. Like those are actually alerts on my account when I was testing. So that means I'm seeing real data from my account on this attacker's profile from their session. So I'm in there, I'm looking at it, and even though the images are broken, on the back end, if you look at them or just highlight over, you'll see that there are AVI file names. And if you go to the AVI file name, they all work. And they all work. They're actually hosted in Amazon, which isn't unheard of course. They're hosted in Amazon, but as a former big, huge Amazon operations guy, you can do a lot of cool things with Amazon for authentication, for signed URLs, all this good stuff. And they were doing none of it. Their HTTP calls were returning unencrypted URLs for your video, so you're streaming all the video over unencrypted. Again, no credentials to authenticate. You just click a link and go there. So you get this data, and so the trick is, oops, I guess I didn't want to do that. The trick is, you have a pretty finite amount of key space for these camera serial numbers. You make a HTTP call. You get the results of all these alert videos. You loop across those, and you download every single video for every single camera for every single account. And keep in mind that these are videos that are automatic. You might get a notification on your phone, maybe you don't, maybe you look at your notifications. Based on some people's inboxes that I see on their phone, they probably don't check certain things like camera video snippets and delete them every day. So if you don't delete the videos, you're gonna have a bad time. And literally every single video that is accrued automatically when there's a noise alert or a motion alert in the room with your baby is all up there, and I can get all the videos off that account. And again, one really, really dumb session authentication authorization thing. Philips, we're doing okay. Philips, very quickly I was like, hey, this looks familiar. So in 2013, I did research on this eyes on camera that I actually had in my home and was using, and kind of stumbled upon some bad stuff. This is the inside firmware page of a web interface for this camera. That's the inside firmware page for that camera. You can see that it's the same kind of firmware, right? So the question is, like, within firmware, it's been 2 years. I reported bugs to STEM Innovation. They fixed bugs. Their stuff was better, and cool. So a really cool test is, did those bugs ever go upstream? Did they ever tell their manufacturers about bad things happening? And the answer is no. So they still, and I shouldn't say still, this camera specifically, I'll just be friendly. This camera specifically doesn't have any SSL on the backend web service, which does all the API calls and everything else. This camera has multiple hard-coded accounts in it that are the exact same hard-coded accounts that were on the firmware from the camera from 2013. It's running Telnet by default until like the very last patch when I was working on it. They finally disabled Telnet. Wait for that though. And then you have an insecure upgrade process, and so you get your firmware over HTTP, and then you get the MD5 sum to verify integrity over HTTP. So I can just man in the middle both, do a backdoor in your firmware, change the MD5 sum to match, and now it's going to be like, yeah, this looks legit, because nothing's signed. There's no signing of this firmware. There's no signing of the manifest for the checksum. It's just taking it. So a couple things. The camera itself, the camera model number is B120. The root password is B120 root. Okay. Let's see, where do I want to go next on here? Let's go to this one. So one of the issues I reported to the other vendor about their device was that they had a hard-coded admin password. So the actual backend web service that did all the API calls for all the mobile stuff was hard-coded. Not great, right? What this approach to this mobile app they did is they have this function called generate cam password. And it's like, okay, cool, they're generating a password, and you're like looking for like a random function, well, you know, something generating with some sort of entropy behind it. This param string that they're running this operation on, so you get your param string, you do an MD5 hash of it, and then you get the first 10 bytes back, right? You're truncating 10. That param string is literally the MAC address of the device. So if you are anywhere near this camera on a network and you can just ARP-A and see all the camera OID and like be like, oh, that's probably a Philips cam, that's probably a Philips. You can literally just pass that passphrase, MD5, truncate 10, that is the admin password for all the API calls for the backend web interface. Everything I can do with my own camera, you can now do with my own camera just because of MAC address. And I should mention too, even if you're not on the network, let's say you get somehow remote access to this camera over the internet, it's exposed, which we'll talk about in a second too. This password with just the prefix of the MAC address, again, you have a finite key space at the end of it, right? You know what the prefix of the OID is going to be. You generate the key space at the end. You just hit brute force. You're eventually going to get the right admin password and login. We're going to talk about this a little bit more in a second, so I'm going to finish up with this one. Weaved, getting back to supply chain, Weaved is actually a third party that provides cloud platform services for the Internet of Things. They have a lot of platforms they support, like Intel Edison and some other cool stuff. And so I found that, hey, this is using that for the back end for streaming. That's cool. Let's take a look. And I was going through stuff pretty quickly because, again, 9 cameras, and I found this issue where I found cross-site scripting. And it's like, oh, you know, cross-site scripting, yippee. I don't really care that often. It's not really an exciting bug 9 out of 10 times or 99 out of 100 really. But the trick is I wrote it down. I was like, okay, cool, cross-site scripting this thing. And then later I realized, oh, I actually didn't find reflective. I found stored cross-site scripting. And then I looked harder and I noticed that they didn't do HTTP only for their cookies. So if you combine a couple of things, and some of this is a little bit of a leap of faith for developers in the room, but if you make a typical app, you have user interfaces, you have an admin interface. Very often, more often than not, your admin interface will list out details for rows and tables and devices owned by certain users and stuff like that, right? Like administrative interfaces. If I, at any point in time, set a cross-site scripting attack into something like the title of my device, which is a very common thing you'd see in an admin interface, right? The title of the device in this database. If that admin ever went to that page, it would send their cookie over to me. And I'm not just taking a cookie for my camera. I'm not taking a cookie for Philips. I'm taking a cookie for the entire admin interface for the entire company of Weave for all their platform. Remember the whole like scale Internet of Things and like web part? Like this is like an example where I normally don't care about cross-site scripting that much, but I do when it affects like tens of thousands of devices at once. That's slightly more interesting to me, right? So the last one up here, you see this proxy 7, yoix.net, and then you know, a high number port, and then obviously a URL for CGI bin and a script. Okay, cool. So you go there and it says mobilized camera service enabled. Well, what does that mean? And what is this proxy stuff? All right. So one thing I've been hearing a lot, especially in like news articles and stuff, and it's like, oh, go to Shodan, and on Shodan you'll find every single Internet of Thing device on the internet. Completely not true. The reality is most IoT devices being manufactured today and services has a much more complex services layer than port forwarding. A lot of it is queued, a lot of it is reverse proxy, a lot of it happens where there's no exposed port on the network by road. Like that's just not how things are being evolved. So there's actually a ton of IoT devices you will never see on the Internet of Things on Shodan. You are not seeing everything, you're missing a lot. So how this device specifically worked, the camera's on your network, clear text of course, talking clear text of course, it's on your home network. When your phone says, I want to talk to my camera and see what's happening at home, your phone talks to the backend service of the vendor. The vendor would then actually port forward via reverse proxy your camera, your full web service, your full web server, onto the public internet on a public host name and a public port unauthenticated. The entire web service of that camera is now directly on the internet, past your firewall, past your NAT, past everything. Right? So that's bad. Where this gets really, really bad is that web service, you remember that whole like MAC address, and like if you could figure out the MAC address, you could have the admin password? That's bad. And so if I were to say to you, okay, you put this camera on the internet, the camera's exposed on the internet, and I have, again, a finite number of combinations, and I can brute force it. You'd be like, yeah, that's bad, but it's also not like trivial. It's gonna take time, the camera could go away, whatever. What if I told you that the camera, when it gets exposed via this reverse proxy, is pre-authenticated to admin? So any URL you go to on the public internet on that proxy port is already with admin rights. What that means is I can literally go to that URL with another proxy number, another high port, / stream temp, whatever, and then a playlist file. I can open that in VLC, and I will literally stream your video and audio to your camera with no authentication. You can then do fun things like go onto your team chat and be like, hey, click this URL, and that URL that I alluded to a bit ago, this cam service enable CGI, if anyone goes to that script, all that script does is start telnet D. So they may have disabled telnet D in the image by default, but you literally can go to an unauthenticated URL on the public internet and enable someone's telnet daemon for them. And as David Adrian says, like, enumerating the number of proxy hosts and the number of possible ports in those proxy hosts is actually a really small amount of ports and hosts. That's a very small challenge for us today. So if you just scanned this range of these hosts and ports all day, every day, you would find live cameras very often. And then when you're hacking on devices like this, like you have to do funny things. So Charlie Miller, Chris Valasek, and so my contention to them that Chris agreed to and Charlie said no to is that instead of having calc.exe when you do a POC on Windows, you do the guys in tracksuit when you pop a visual interface. So I basically took the abuse of the credentials, the open proxy, X, Y, and Z, and made a script that when it got access, it would just upload this image and force it to loop over and over and over. So you would always see Chris and Charlie in tracksuits on your camera. And so next example, Summer Baby. Summer, if you have kids, you've probably seen Summer in the stores. They're a huge baby brand, but they do have some technology. And one of the technologies is this camera. So one kind of thing that seems pedantic, but also is kind of terrifying, is that you as consumers very often sign up for services and you create a password and you use your password. And sometimes you get a default or a generic and it's like, okay, here, type in these weird characters and change your password. What Summer did is that when you created your account, you would not put a password in. They would email your password, which I'm not gonna whine about emailed passwords. That's the least of our concerns right now. This password is literally the person's last name they entered, truncated to 8 characters, plus a group ID. And the group ID is an integer, and it's a serial integer. So if you know, and by the way, you're not actually forced to change this password when you log in, so it's not really a good default password. When you know that someone has this camera, or you somehow get info, like an info leak to a customer list, or whatever you want to make examples for, you do this, and now you can literally just do their last name, truncated, 8 characters, register an account, get your ID, and just work backwards and forwards. And I guarantee you'd get 80% of all accounts for these consumers. Now this is a really a longer tail, more involved attack, and you have to have some things go really right. What if we just skipped all that? First screenshot is me logged in. Second screenshot is an attacker now on my account. And it's like, okay, well that's not good. How would that happen? And the answer is you curl this URL. You put in the attacker user first name and last name you want, which I don't recommend attacker user if you're actually breaking into stuff. That's not a great idea. You attach the email address of the attacker user. You give them the privilege level of the account, and then you say what group ID. And what a group ID is basically the account ID. The group ID, again, is a serial integer. So you, again, register an account, get your group ID. You run this one HTTP call in a loop for all integers below it, all integers above it. You are now admin on every single camera in the Summer ecosystem. You log in with full rights. You can turn the camera. You can start the stream. You can do it remotely. And literally no one would ever know, because if you were really a sinister attacker, what you do is add your account, spy on people, and then run the command to delete the account in another post, and your account would go away. There's no email sent to the consumer that a new account exists. There's no indicator that anyone's watching the camera along with you. You just have full access. One HTTP call. Not that the other cameras didn't have the same kind of problem, right? So that is encrypted, so we can encrypt our attack, which is super, super important. So disclosure, we have a really kind of a strict 60-day timeline or longer when it's reasonable. So after roughly 15 days, we contact CERT, and then they try to help us with disclosures. Overall, the disclosures went really well. We had a couple people a little bit latent, only one cease and desist, which isn't bad for 9 companies, which didn't stop us from releasing anything. So here's a high-level scorecard. Still doing okay. So here's like a high-level scorecard. So again, there's a million things you could look at for any device. It's hard to really give a quantitative number or a value to how good or bad security is. People try it all the time. It's very adorable. But I also was trying to be adorable here. And what I did is I picked some like really high-level things that are bad, and I tried to say yes or no. Okay? So you say yes or no, do these things exist or not exist? And then I came up with this completely arbitrary scale about how bad something is bad. And again, I just wanted like some quantitative way to like identify badness. So all these cameras start with 250 points, you deduct points, and where you end up is where you end up. So Baby's super, super unhappy, and the reason Baby's unhappy is because 8 of these cameras received an F, and that camera just like squeaked by with a D. And you even see like the iBaby M6 got literally a score of 0 for security, which no matter what I'm checking for a metric, 0 is never an okay thing for security, right? So again, not a perfect scale, not completely, this doesn't really factor in how bad the vulnerability was or how, this or that, but holistic security, and like what I do at Rapid7, I look at security programs for a company, the whole thing, everything, top to bottom. And so when you look at holistic security, yeah, there are gonna be really bad bugs and really not so bad bugs, but consistently bad practices across multiple areas is actually a better indicator of security maturity than a single bad bug, right? Like if you have multiple areas failing security, that probably means you're bad at security. If you have a bad bug, that means maybe you had a bad developer one day. Who knows, right? So, so that's that part. I think, again, like I said, we're still okay on time. More beer for a sec. Anyone have any questions on that first part, very briefly? Anything comes to mind? Zach?
You weren't able to catch any API keys with the vendor that was using
No. So their API, so I'm trying to think how the workflow was. The actual camera, when it uploaded, I want to say was like a back-end web service. It wasn't actually using Amazon APIs to upload content. It was just sending data unencrypted over the internet to a web service somewhere. So no, not so much. In terms of finding other things other than like root credentials and all this other weird stuff, one of the devices, which I won't name just because I didn't report it to them even though it's not really a bug, they had multiple email addresses to literal Gmail inboxes so that they could send data from your camera to their they're literally a Gmail account guy. I'm not making like light of that. Literally a Gmail account that they signed up for and hard-coded credentials for that account into the mobile app. I mean, what's left, right? Like, where do we go from here? So like I said, I left a lot out, and that's like one example of the kind of crazy stuff that I left out even. So Fisher-Price Smart Toy. This was actually in like some, I think, Super Bowl commercials somewhere in the background. So Fisher-Price came out with this line of Smart Toy, which from what I could tell from the mobile app reversing was based on the Ubly platform. It's like UBOOLY. Weird looking like little characters. It seemed like the mobile app at least had a component of that, and the toys are kind of similar. So guessing it was at least maybe a license share or something like that. So Smart Toy, Android-based, as we'll talk about in a second, has Wi-Fi, has Bluetooth, a really bad camera in the nose of it, and two-way audio. Basically what it is, stuffed animal, children can interact with it. They have like little cards they can hold up in the nose, and it'll like play a game or sing a song or whatever. It's like a very low-tech way for kids to interact with this smart toy. And then there's a mobile app component that parents can set up an account that basically has their kid's profile info. Dun dun dun. And then the parents can also play games. So like they can say, oh, you should play this game for my kid right now. Okay. So that's what Smart Toy does. Getting into Smart Toy was not my finest work ever. It was really not. It's a really well-designed piece of manufacturing, I guess is probably the right word, because these things like are all stitched on top of each other, and like there's a button in the leg that goes out and it's stitched inside. So it was actually a really complex for me, anyways. It's much easier when you have a bunch of screws than a teddy bear's like skin to cut through. It's a lot less disconcerting when it's just screws on a plastic shell. So eventually I got into it, and it's very sad. And so one thing that I missed the first time, and this hopefully happens to other people when they're looking at stuff, I was like, okay, there's a USB port there. Let's plug USB in, see what happens, and see if like these things are exposed or whatever. And it was just USB for charging. I was like, oh, that's not super interesting. But when you open up the shell, that USB is actually attached to some pins on the other side of the board. I saw this USB, and I was like, oh, like that USB, like the buses probably just connect, and it's probably just like, another anchor point for the same USB. No, it's not, actually. This is actually the really good fun one, and it's really fun because this device is literally running Android KitKat. So ADB shell, you're root. I am now root on the Smart Toy. Very, very quick effort, no dumping of flash chips, no desoldering things. So you get, you got to do your I have a shell command, take a screenshot of all the things I have access to that no one cares about, and then you open up the default Android file transfer, and you're like, oh, that's pretty cool. And then there's this ADB command, which ADB is like the interactive shell that you can do with Android devices, and you can just do an ADB pull and just take the entire file system straight off of the device. So again, very simple, very straightforward. But that's not what I want to talk about. So just for your all reference, some other people I've talked to, I won't name names, but some other people I've talked to, I was like, hey, I don't really have time to go through any of the Android apps at all. Like, just so you know, here's a repository of Android apps. You might want to take a look at some of this stuff. So maybe there's more stuff coming out. I don't know. But in the near term, again, mass exploitation, mass bad things happening. The accounts themselves, you have to authenticate to do anything. Okay, that's fine. You should have to authenticate. What's problem is I basically went through the mobile app for the actual toy itself, not all the APKs on the actual device. And in the mobile app, I saw all the API calls. I was like, well, API calls, cool. I'll take a look at these and see what happens. Not all of them, but 12 of them, at least the ones I tested that I cared about from looking at what the API did, 12 of them were exposed in such a way that as long as you had a valid session, you could run any API call against any account. Okay. So what can we do with that? We can retrieve the customer's toy details, which includes the profile ID for their account, the toy ID that's attached, the name of the toy, and the kind of toy they have. Where we get like kind of really disconcerting is retrieve any chosen child's profile. So their name, their birth date, their gender, and their language. And again, this is an HTTP call. We can just literally enumerate over all these profile IDs and get every single child's detail. And we know which toy belongs to which child. Okay. We can also see when the parent is actually using the mobile app. So are they around? Are they doing stuff with the kid? We can see when the kid's using the toy. We can completely alter, create, edit, delete profiles on the parent's account. So when they log into their mobile app, they actually see the profiles for the accounts of the children on their mobile app. We can change the name of any child. We can add profiles, delete profiles, be obscene, troll them, whatever you want to do, right? One of my favorite things, although the outcome isn't quite as exciting as people might want to clap for, one of the cool things that you can do is you literally can take any toy and reassign it to any account. So I can know all the details of the child, not that it's super relevant in this case, but I can know all the details of the child, take their toy, and then just start making the toy play games and say things. And it's not all that scary, which is a good thing. I'm not saying it should be that way, but it's not that scary because it's all pre-programmed. There's no like natural language processing stuff. It's just all pre-programmed WAV files basically, and MP3s or whatever. So not the huge risk that you're gonna like troll the child literally and yell at them. But still, if the kid's sleeping and you start like saying brush your teeth, and it's like, maybe that's kind of a psychology in their future sort of thing, psychologists. And so you create profiles, delete profiles. So what's the result? You can steal all the kids' information, which isn't great, of course. You can make the toys do whatever you want with or without the child or parent's desire to have it happen. You could add like accounts and delete accounts and change profiles for those parents. And ultimately also know like when the parent is probably around the child and when the child's playing with the toy because of indicator statuses for the API. So I mentioned there's a camera on this. The camera, from all the analysis I did, is literally within the device itself. It's not going out. It's not transmitting camera images. All it's doing is looking for these cards that's like, there's a little backpack that comes with the toy. I need to explain this. There's a backpack that comes with the toy that holds the cards on the bear, so that if the kid wants to brush his teeth and play that game, he holds up the toothbrush card, and the camera has enough resolution density to be like, oh, that's a toothbrush, I guess. And so you have this thing where the kid can interact with it. It's very low tech, but again, the data, it's not going out. When the toy talks to the child, there's a pre-programmed list of names that the toy can say. So you can't just, again, make up a bad name and call the kid that from now on. So they've actually, and to their credit, right, like, this is bad, without a question. But through their engineering time, they clearly made decisions that were at the benefit of overall, if this happens, what's the worst that could happen? Not great, still really bad. PII of children, not okay to get rid of or lose, but still, this could be a lot worse. And I've personally seen worse examples. So where this ends up is you do like dumb stuff, like the name of the account's guest. I for some reason I think Captain Phillips came to mind, and I was like, I'm the captain now, and so I named the bear that, or the account that. So you can change the bear's name, you can change the kid's name, play all these things whenever you want them. Start one, go to the next, go to the next, go to the next. Again, harmless, but probably annoying and really kind of scary for people. So disclosure went well. This one was a little extended just because of timelines, but again, Fisher-Price actually worked, and I shouldn't say actually, Fisher-Price worked with us very well. They were very responsive. They got bugs fixed very quickly. So really good experience with them. I really can't say anything bad about their disclosure process or work with researchers. And the last one, oh wow, I'm really doing good on time. And the last one is Hero. And Hero you probably haven't heard of, but I'll try to give you a quick heads up. So Hero's two things, and I refer to this as like the Hero GPS platform. Hero is a mobile application, and Hero is a smartwatch for children. The smartwatch itself, as I'll say in the next slide anyways, the smartwatch itself is actually in beta, so some people have them, some people don't. It was actually an Indiegogo campaign originally, so some people have them. They're not fully to market. I didn't have a smartwatch, but what I did have was their Android app, and that's good enough in a lot of cases. So a little bit more detail on what it does. So the Hero platform overall, you have to think, I think the best way to think about this is that the mobile app and the smartwatch are clients. You have a service backend, you have clients. So it doesn't really matter what the client is, it's a client that has information, data, and whatever else. So the actual smartwatch, it has GPS built in, it has GSM built in to actually do cell operations to transmit data from the kid, and some other basic chips that you would expect on a smartwatch. But it's really dumb, it's really like low level, it has it's made for like very young children, right? So it doesn't have like games on it or anything like that. There are features like geofencing with alerts. So I can say when you leave this zone, you should tell me that person left the zone. There's also a full location history in the platform. So when people go places, you get a history of that long term. Longer tail, I think they finally implemented this, but there's a text message feature so that a parent could text the kid's wrist and it would pop up on there and say like, come home. Again, very practical. And then, a cool safety feature, a panic alarm mode where the kid, I think, has to press a button or something or twice or 3 times or something. And what it will do is every person in this family unit in the app that you assign privilege to, they all get the location of that person immediately, and it goes out to everyone at one time. So again, good safety feature, kids platform, makes a lot of sense. Indiegogo originally, and then they posted they got $2 million of outside investment, so not a poorly funded company by anyone's imagination. The mobile app, even though the smartwatch is still not on the market fully, the iOS app at least has been out since March 2014. The Android app, I don't have an exact date on, but it's probably pretty similar. And so that's kind of where we're at. So I had heard of this before, I had seen it, and I was like, this is something I should eventually look at, but the watch didn't come out. And it's fun to have the hardware to hack on and learn some stuff. So I was like, nah, I'll do it later. And then I had a later moment. I was like, okay, time to look at it. So I did. How many people are developers of some sort or another? Okay. I want to see if this resonates with you as much as it resonated with me. So you have a couple of things up here. I'll walk through them. So you have a user account creation operation. So you post some data to this place, and then you get back details, one of which is your user ID. Okay, so you got a user ID for your account. Makes a ton of sense. You have another thing where you log in, you have a user ID, you get that back, you get your session back. We're still in the reasonable realm of what happens on API calls. I don't want to say anything about like perception, but this I saw in 5 minutes, and that was all I needed to have happen to like go the rest of the way. And it's one of those things you get lucky. You look at the right API call, the right line of code, and you just see the thing you need to see immediately. This user invite up there, okay? So user invite is the way that you have a family unit, and then you say, I want so-and-so to be part of my family unit. You invite them to your family unit. So the parent invites the children's watch, the children's smartphone, whatever, cool. In the actual post that's being sent, the request and whatever, the way it shows it, this is passing the user ID for my account as the owner of the account, and it's passing my user session as the owner of the account to invite someone. When I saw that, I was like, man, I've screwed up some code in my day, and one of the things you do very easily is that you are making assumptions on what data should be used and user controllable, and what data is on the back end and not user controllable, right? So again, everything comes back to some extension of user control when you have an attack like this. This is a weird thing to see, and it's weird because it's redundant. You should never have to pass a user ID when you have a session for that user. The user ID is already on the back end. We already know what the user ID is. So maybe 9 out of 10 times, I don't know, take a fake number. This is a red herring, like it has nothing to do with anything. It's just like the developer was lazy, forgot, added it just in case, whatever. This is not one of those cases. This is the bad case. So what happened is maybe this, where they had some extra data and they now use the wrong one. But where we ended up, and I'm gonna have to I have to read this out loud. So we have an attacker account, we have a pawn account, and we have a target. The pawn account would be owned by the attacker, so I'd create 2 accounts. The pawn makes a user invite API call. They use their own user token, and they set the attacker as the recipient, and the target ID, which is, again, you can enumerate, like, again, integers, just pick random people. It doesn't really matter at this point. You pass the user ID of the target along in that query. So what happens is my pawn account requests someone to be part of this family unit or whatever, but they send the request to the attacker. The attacker gets the invite link, they click it, they accept it, good. The pawn receives an email notification that says the attacker is now part of your family, cool. This part we'll talk about briefly more in a second. The target receives an email that says the attacker, in this case, was added to your account. Okay, that's kind of interesting, but not a deal breaker. Immediately after this operation, the attacker now has full access to the target. And so the email part, just because I want to put strong bad in here more than anything, the email part, this is what it looks like. So the attacker is invited, they accept it. The pawn is told the attacker accepted it, cool, good news. The target is told the attacker was added, but we control all the detail. We control, and by the way, I didn't like write this in here or have a screenshot of it, but the actual name of the account, like the first name, last name, I was able to put actual HTML, and it didn't parse it out. It didn't do anything. So you could literally like iframe in something into like an email, or JavaScript into an email, or whatever will render into that email interface. And so you can make a name, a first name, last name of, this is a system test, please ignore, joined your family as a friend. And it's like, okay, cool, like it's a test, big deal, delete, carry on. So in the actual, like how this works, here's your little map. You're the attacker user, and yes, I named all these things the way that they're said because it makes sense. So the attacker user, you send the request, attacker accepts. We now have the target here, as well as the attacker on the account, and then we see where the target is on the map. We have the full access. We didn't like abuse some complex API. All we did was add ourselves to an account. So every privilege, every history, every feature is fully within our rights now. Like, we don't have to do like additional attacks. We just have an account that's associated now. It's like inviting someone to Facebook, having like a CSRF thing that you make them click on, and now you're a friend of theirs. That's all you did. You literally have full access to everything within this account. Again, much longer timeline on this one. This was a little more shaky on disclosure, but we got there. Everything's all good now. So that went well. So that's the research portion. A couple things to end with. Build securely, which Zach Lanier and I started 2 years ago, I guess now. So we have both resources to help IoT engineering teams not do these things, as well as working with pro bono researchers for IoT vendors that want some help. The OWASP IoT Top 10 exists, and so gives guidance on the big hit list stuff like our normal OWASP Top 10. The Online Trust Alliance, which I'm working with, has an IoT trust framework that we're building. So this goes over both privacy and security concerns, so that vendors will have like that checklist almost of like, did you actually use SSL, and make sure that like SSL Labs says that it's not bad, right? Like we go a little step further where we can to make sure that people aren't just doing something to check the box, they're actually thinking about the implementation as well. Which again, it's not perfect, but right now there is no checklist at all for vendors. They have no guidance, and we're trying to help solve that. And then Google has some stuff, Brillo for a hardened, stripped down Android version for IoT, and then Weave, which if John is to be believed, which I guess he can be, is built into a couple of their products already, like the Nest. So we're seeing things change. Things are getting better. Obviously, these devices are not good examples of that, but there's been a lot of effort, and a lot of vendors are actually maturing quite quickly. This is a big space, a lot of vendors, a lot of entrepreneurship, a lot of people that have never built products before. And so the mistakes that the mature engineering companies make, or made like 5 years ago, 10 years ago, or still make today, just massively increase those numbers. Every single device that comes out on the market probably has at least one good bug in it. I mean, realistically, just because when you have mobile apps, you have web services, you have third parties, you have hardware and all these things, the complexity is so much, and it's really, really hard to get right. So we're trying to help people get a few more things right and solve some bugs in the process. And if you don't fix these things, then Nick Prococo will come after you with his weird baby t-shirt. And ThoughtCon has like 55 tickets left, so go register. I am on the agenda. I'm not actually speaking there, but don't mind that. So that's all I have. Hopefully that was okay it was okay on time. So there's some contact details if you want to reach out, Twitter and email. I have some business cards with me. But any questions I can answer? Yeah. So this is when we contacted the vendor, when we contacted CERT, and when we disclosed. Okay. Yep. So this is our actions basically. Yep. Yep. Zach, you have something?
Yeah, I just talk about all the vulnerabilities here about devices, the Internet of Things. Oh. Oh no, we're good.
That's a terrible question.
So what can, if we have the Internet of Things, currently within, we're all more connected than I'm not even doing anything. What can we do to protect ourselves, right?
So basically, like what consumers buying Internet of Things devices do to protect themselves. So I think there's some good guidance out there and some bad guidance. Honestly, a lot of these issues, if you don't have hard-coded credentials, you can't change. Honestly, like still changing default passwords is a really good first step. Disabling features you don't use on the camera or any other IoT device. So a lot of the attack surface comes from the complexity. If you disable features that you don't need, I mean, if you need them, use it. You paid for it. But if you don't need it, turn it off. If you can turn it off, right? You're reducing.
Yeah.
Damn it, Rich, you listened to this talk apparently. So yeah, if you trust your vendor to turn things off when you say to turn them off, yeah, that's also a good thing to do. Some people say like, oh, I'm going to put all my IoT devices on a separate VLAN or a different Wi-Fi network. Yeah, that totally helps protect maybe your internal network from a compromise, sorta. But what it doesn't do is almost any of the things I talked about today. These are all web services. These are all backends. These are all centralized things that you cannot block, otherwise the device stops working. So again, if you threat model each of these devices, you're probably not going to be super happy with your options. A lot of it's vendor trust. I mean, we trust vendors all the time with everything we do. That's not a shock. I would say, pick selectively what you put in your home or on your person, as it were, with smartwatches. I would also say be selective in where you put things. So if you have cameras, for instance, put the camera in the high traffic zone where people walk through but don't hang out in. Put them close to the windows. Put them outside your home. If you're worried about people spying on you, reduce how much they can do or spy on you. Again, this convenience we've all lived without. You can live without it still if you really want to. Don't feel like you're pressured into doing it. But overall, we've seen dumb things happen. We've seen some really good research, but we haven't seen major attacks against people's home en masse. You get the spying person on a webcam all the time. I think that's kind of obvious how this happens. But overall, nothing super terrifying within the home has happened. Charlie and Chris, I think IoT, if you want to consider car hacking that, which I think is well within bounds, that's pretty terrifying. So it's risk tolerance for you as an individual, I think, and your family. Yeah, sir.
I'd like to comment on your point about the lack of cryptography on streaming video. It is to the complexity and the laziness of developers. All these devices have Wi-Fi radios on them. Every single Wi-Fi radio has AES hardware CCM mode of operation with the API pretty much exposed to the higher layers to be able to send your frame down and run CCM on it and get it back real time, faster than you have to communicate over it because it's able to handle the radio. If it's an 11AC radio, it's GCM. So it basically shows that the lack of knowledge that developers have, that there are tools available for them to provide those levels of security. The final thing I would say is that there is serious research being done on very lightweight block ciphers, new hashing digital signatures and other items which are coming along. I helped one vendor that has an 8-bit processor implement Curve 25519. It takes 9 seconds for them to do the join, but they only have to do that at the time you install it. It's a one-time operation so that it doesn't kill their battery too badly. But there is some serious research being done for the low-end devices. But if you got at least a 16-bit processor, 100K of memory, it basically shows the lack of knowledge that is rampant in this industry.
Yeah, and I think one reason why is a lot of these people are not embedded software developers. I think that's the disconnect. These people are general consumer electronic people that they take an existing board from an existing vendor and they smash software on top of it. They're not doing engineering themselves. So that's, if you look at the Linux ecosystem that I showed, these people are not touching the software. They literally put up a light HTTP web server. And that's literally all they're doing on that software. So when they're sending packets, they're saying, okay, let's send literally HTTPS packets from this to that on the internet. In terms of benefiting from exposed APIs on Wi-Fi chipsets, way outside the scope of almost any engineer I've talked to in a room.
They have no knowledge that this is available, that there is a call available to them for these items. And because it's not in the JSON or other community, which has nothing to do with IoT, they don't know.
Yeah, no, I think there's absolutely a lot of truth to that, and I don't know if that's something that you've seen written up anywhere, that people have said if you have these constraints on your crypto, look at these options to solve that within the other parts of your system on chip or whatever you might have. That's definitely not something I've seen written up in any way that would be palatable for a developer community.
They tell them, use SHA-256. God, is that a mistake for anybody doing this? Use Blake 2S.
If I could find a developer that knows what Blake is in the general community, I would be shocked.
Exactly.
Yeah, and so it's an education. So build securely. We have engineering documents, white papers, presentations, because the disconnect between security professionals and everyone else is pretty rampant. So it's our job to communicate. It's our job to be the Neil deGrasse Tyson of security. We have to talk to people that don't necessarily understand what we're saying. We need to not talk down to them, but we need to educate still. So anything that is published, we're always glad to post on Build Securely, share with our developers and our engineers, because more often than not, people want to learn. They just don't always know what the questions are to ask. I had never heard of what you just said, and I talk to IoT vendors day in and day out. And so that's a good indicator that even someone that's informed like me is completely out of the woods when it comes to the very, very creative solution that you have.
All under NDA. I can't tell who I worked with, but let me tell you, they're really important because some of their current stuff out is so bad. And in fact, if you want to see some of the history on this in other arenas, look on the Kaba lock. It's a physical lock. There's some 2 to 4 million of these sold. The lawsuit against them, it just took a strong magnet to open up every single Kaba lock.
Was that IOActive's research?
You can go back Forbes magazine 2-3 years ago, you see it. But these locks are on police stations, doctor's office, medical cabinets, and just one $25 lock opens them. It is a 50-cent piece of steel to block the magnet.
Yeah, threat modeling apparently didn't happen there. Any other questions from? Yeah, please. You want to grab the boxy thingy?
Yep, your turn.
The box. So it seems to me like all these products, they really, just their intention was just get it to work and not think about the value of the information that it's, conveying. It's privacy stuff. It's, what was the one, you put it on a kid and it's like security of where the kid is or something like that. But they're just not thinking about here it comes, what could be done with it, and try to stop that. It's just like get it to work. It just seems like
Yeah, and part of it is, again, to harp on the ecosystem thing, you have, from a lot of the IoT companies I work with, they are really good product designers. That's where they excel, is making beautiful designs that are really functional, very aesthetically pleasing, whatever. Where things fall apart for a lot of people is they then have to decide, are we going to hire someone full-time to do this work or outsource and get the project done? Almost always they're going to outsource. So if they're like, hey, we need a mobile app. All right, pay a mobile development firm X money and they get the mobile app and they do it. So the incentives aren't really there. You have very few people, not always, but a lot of the time there are very few people that are full-time employees to that company. They're not living, breathing, and dying in that company. They're not vested. They're not startup shareholders. They are literally just being hired guns for that part of the project. Because if you look at all the pieces of a normal IoT ecosystem, you would hire a gigantic IT staff. And then you have to hope that gigantic IT staff is all security proficient. Not going to happen. So I think this is one of those things where, again, engineering documents and guidance and checklists are a good way to start. Ultimately, a lot of these companies should be working with security firms and getting stuff pen tested. That's, again, if I can find that code thing in 5 minutes that affects a $2.25 million invested company, there's probably a systemic issue there with their engineering program, right? That's kind of obvious. So,
can you compare this, what you've been presenting tonight, to Apple's HomeKit? I don't know much about it myself, but just how that may differ.
Yeah, so HomeKit is kind of like a means to an end to interaction. I don't actually know the underlying details of the protocol and how it, but it's basically marrying underlying. It's basically marrying disparate components to be able to speak to one another. The HomeKit thing's interesting. What I find more interesting, and I remember Zach and I had this in a talk, was my concern is things like if this then that. So IFTTT or whatever it is. If this then that, you have 100, more than 100, 200 platforms, services, devices that all connect APIs in. Last I checked, they don't even have two-factor authentication, so they probably should deploy Duo immediately. But the overarching problem is if I can steal a credential and I can log into your account, I now have access to all of the APIs for all the devices in your home. That's bad, but imagine if there's an API flaw. Now I can not only take the API flaw, or the overall API, and abuse that for what it's supposed to do, but let's say there's one of the APIs passes a serialized object. And now I can arbitrarily pass a serialized object over that API, and now I can do code execution or something, or read or whatever. So the interaction of HomeKit is kind of concerning. I think a lot of it is really as the name kind of implies. A lot of it's local area network focused. I don't know if HomeKit features work outside of the home. Does that anyone have firsthand? So I don't know where those connections start and stop. But any of those like super set of protocols is kind of an interesting thing. Certainly, if you can find a bug, that's a really cool thing to attack. But I definitely worry more about like the really bad web APIs than probably HomeKit's abuse potential. But we do see people put out research on like attacks that are directly at the home, whether it's a Zigbee attack or Bluetooth Low Energy or basic Wi-Fi things. We still see WPS bugs with Wi-Fi. We see hard-coded 0000 Bluetooth pins. These things are problems, but again, the internet scale is what really I think concerns me most. So. Any other questions? Zach, you need the box thing again.
So I might be showing my bias here, but do you think that Amazon Web Services IoT would help mitigate some of these vulnerabilities that you have found?
Yeah, so Amazon has literally a whole IoT SDK. I don't know what it does. I assume what it does is it combines a lot of API or Amazon Web services that will then allow you to enable things like message queuing and communications and all these other things. In general, Amazon's a pretty rock solid company when it comes to security over the history of the organization. So if you were building something new today and you were an Amazon Web Services customer, I would absolutely look at it immediately. I just don't have firsthand experience with what's longer tail. Like if you look at the Amazon Echo, that is a definite IoT application, and as we know, Amazon likes to dog food everything, and the platform supports other platforms they build. There was recently, I think as of like last week, they finished it. There was a competition from Amazon Web Services for IoT development. So they had a competition to bring ideas and develop things and whatever else. I forget what won. It wasn't really that interesting. It was like a drone that did something, but drones are everywhere, so who cares? So this is a longer tail thing that I think Amazon is showing what they've been probably building their own products with, and this has now come out to the consumer or the developer or whatever.
Follow-up question, are you going to look at the Amazon Echo next?
Some people have looked at the Echo. I haven't seen any like research that was like, oh my God, why would you do that? Again, they're a really mature company. I think they have really good engineering. I'm not aware of anything like terrifying with the Echo offhand anyways. Other questions? Yep.
So has anybody looked at the cost implication for developing something that is secure? And is the market willing to pay the price?
Yeah, so I think the latter part, though, is the market willing to pay the price? Again, the $260 baby monitor that I bought to test, that is well within a world that people are paying a pretty hefty price for a utilitarian device that they'll use for like 2 years. The cost, I think people are willing to accept. Nest is not a cheap device. Nest cams are not cheap devices. But I think as the research showed, bottom of the barrel pricing does not have a strong correlation with better or worse security, right? Like the low-end cameras. The low-end cameras and the high-end cameras had many of the same bugs, many of the same failures of secure engineering, of practices, whatever. So you can buy from vendors that have a good track record and hope for the best. You can buy from vendors that you've trusted before for other technologies that haven't really steered you wrong. But other than that, it's completely a crapshoot. And even if you buy from vendors that are good, they're probably going to have some bad bugs once in a while too. A lot of the research, like I mentioned, to some people earlier, some of the research again, like Nest. If you have to take the Nest off the wall from someone's actual home, open it up, UART to it, developer mode, debug mode, implant malware, put it back together, put it back on their wall. That's not really something that you're going. Yes, there are. You can do code signing. You can do firmware signing. Sign everything and be happy, and everything will be fine. As an example of that, Belkin had signed firmware. They had a process to do the signed firmware. It was a good process, and they accidentally left the private key for GPG on the firmware one time. One part of the code train. So all these code trains for all these devices, one device. For one update, had the private key in the firmware accidentally. So this is the equivalent of you accidentally add something to your Git repo, and then you're like, oh, no problem, and then you forget to actually purge it from your Git repo. That's what happened to them. And so you have this security model that now is completely flawed. All the code signing is all, firmware signing is done. Some of the IoT vendors I've worked with recently, very recently, they have a line of consumer IoT coming out soon-ish, as far as I know anyways. And they've been looking at, I'm forgetting, it's like the i25X, like Freescale, like i25X or some weird thing. And it has a sign chain, boot chain. So you can sign everything up. You can have 3 different private keys for 3 different layers of the execution. But we talked through threat models, and they really didn't think of some of the threat modeling I did about some of the key concerns and X, Y, and Z. Like, oh, okay, so you're going to sign this stuff, but then the operating system itself is still vulnerable. So if I find a code execution bug, I can drop in a module and set up a ins modit, and now I have a kernel module hooked into. That's not signed. It doesn't need to be, because you trusted the boot. You didn't trust the actual entire environment. So it's always a thing where you're going to get close, but you're not ever going to get there. And at least getting the low-hanging fruit out of the way is probably a good place that we should start.
One follow-up question. Is there a place where consumers can look at it in a user-friendly manner as to the security threat or the security, how good a security is in a device before they buy? Because, we understand it as developers, but I think general public is not going to even understand why should I pay $500 when I can get something for $100.
Yeah, and that's one thing that Zach and I were asked many times to do was like put a build it securely label on a box that we looked at. One, we don't want to ever have that much liability. We're not Underwriters Laboratory. We would get sued to oblivion. But 2, I should say that the Online Trust Alliance, while they're not doing it now, longer tail, they're the kind of organization that has the legal backing and financial backing, not Zach and me, to maybe do that. I don't know if they're going to do that. I don't know if that's an approach they might take. But certainly we're getting to a point where, and if you look at so Mudge, who spoke here, like John mentioned, Mudge is actually running basically a cyber underwriters laboratory for the government. And of course, one big focus of that's going to be IoT. So there could be government top down, there could be market bottom up. I don't know what the answer is. Right now, there's no answer to that. There's no security label. We've tested this. We had a pen test. There's just nothing.
Anybody who's doing security right in IoT space?
Nest gets a lot right. They've had a lot of misinformation in news articles that people were trying to hype up research that wasn't really research. So there's a lot of misinformation with Nest. Overall, I feel really good about them. Dropcam, before they got acquired from Nest, I had a chance to talk to the whole engineering staff one day in San Francisco, and just impressed beyond belief of how good all that team was. Obviously, a lot of it's rolled into the Google team now doing Nest, but overall, really, really good example. And then, of course, Amazon with the Echo. I think, again, I don't know of anything critically wrong with the Echo right now. But again, tomorrow could be a different day. glibc bugs on DNS resolution. Where are you going to threat model that one? It's a hard thing to win all the time. So,
thank you.
Any last questions? Good. Okay, well, I hope you guys enjoyed the talk. Thank you very much for coming out. And again, if you want to have any more chats, feel free to email me. So I do have a handful of books that I wrote about two-factor, not that you haven't already bought Duo, but if you ask a question, be somewhat honest because I don't remember. Come up, I'll give you a copy of the book till I run out. So thank you very much. Have a good night.